the question from Jacek, shaping versus policing. It looks nice, assuming there are no problems with buffers on the shaping side. You are absolutely right. Shaping works really well only if you have enough buffers on the shaper, so on the router doing the shaping. The other assumption is that you're doing this to applications that respond to delays. Shaping TCP makes perfect sense and will give you the nice results you have here. Shaping UDP will not give you anything. Shaping voice over IP packets will just annoy your users. He says if the buffers are shallow and you have many flows, so the moment you get into packet drops, it's getting to look probably as policing. Actually, no. Because if you have like 100 or 1,000 TCP sessions flowing over that single link, then statistics will work and you will get pretty flat line. Just ask any ISP with high-speed links. They get almost flat line even if they do dropping. Because if you drop packets, random packets from individual sessions, those sessions will back off. So you will relieve the congestion a little bit, but the other sessions will not be affected. And if you have plenty of them, if you have, statistically speaking, enough sessions, you will get a nice average. On this slide, the trick is that we only have 4 sessions, and therefore you have the jagged line on the top. Next one, does the convergence of the network affect the time as well? Of course it does, because if you have convergence in the network, then obviously some packets will be dropped and you will have to retransmit, etc., etc. What we're discussing here is under ideal conditions. So the moment you get network convergence, all bets are off. A comment saying TCP fast open would also break most load balancers. It depends on how you do the load balancing. If you do the load balancing based on source and destination addresses and port numbers, let's say if you do the load balancing based on source IP address, then TCP fast open will work well. If you do load balancing based on cookie, then the question is, will you get cookie in the first packet of the TCP header? And if you get cookie in the TCP SYM packet, then load balancing based on cookies would also work, but don't hold your breath. A very valid comment saying shaping and big buffer introduces huge delays, see buffer bloat. Totally agree. The amount of buffers you have in the system should be appropriate for the bandwidth you have. If you have a few milliseconds worth of buffers, then you're okay. If you have buffers that are holding seconds of data, then you will have huge buffer bloat problems. By the way, buffer bloat is a real problem. And although there are some congestion avoidance mechanisms that seem to do better than others, it's still not solved on the global scale. So thanks for mentioning buffer bloat. Next, you mention CDN, but don't mention WAN accelerator vendors. Is that on purpose? No. I do have to admit that the focus of this presentation was primarily on the web applications that are consumed by generic public. WAN accelerators obviously work well only if they are close to the server and the client, which means enterprise networks. Accelerators will not help with the latency. They will help with other things. For example, they streamline TCP, but at least Cisco's WAS, because I was studying how that one works, it still sends TCP SYN and ACK packets across. So you still have that first round trip time, and you also get the second round trip time for HTTP request and response. And after that, WAN accelerator might start doing its magic. At least Cisco's WAS will still have the first 2 round trip times. Not sure what Riverbed does. Another question about WAS. Is WAS a solution or a workaround to this problem? WAS is a solution to a set of TCP-related problems. It can streamline TCP so it gets a bit better performance because of, let's say, higher initial congestion windows and better congestion management mechanisms and so on and so on. And it gives you better performance if it does compression. Most web servers that were deployed recently have compression turned on by default, and all the browsers support at least gzip compression. So compression is not a big factor anymore unless you have very old browsers or old servers that haven't been reconfigured in years. WAS will help you with TCP. It will optimize TCP's behavior, but in modern, well-deployed web applications, there is not that much WAS can do. How prevalent is adoption of fast open? I would say it's still pretty experimental. I haven't heard of anyone running this in production network. Maybe Google does. Of buffering, isn't there a danger of having too deep buffers? Absolutely. That's what's causing buffer bloat. You had recommendation for network and server folks. Does this apply to virtualization domain as well as in virtual servers, virtual networking solutions, and so on? Absolutely. That long list of bullets on that slide I've shown in the previous section. That applies primarily to people developing applications, deploying applications, and configuring web servers. Because what we are discussing now is actually happening between two applications, between the browser and the server. These two applications can run on bare metal servers, they can run on virtual servers, they can run in the data center over VLANs, over VXLAN, over VPN, whatever it is. So yes, that advice applies to all environments regardless of how virtualized they are. Next one, as far as I understand, the amount of buffer you need depends on the average round trip time to your client as well. Yine. It really depends on how much data you're trying to push through. There is the bandwidth delay product, so how much data can be in transit, and the bandwidth delay product influences the buffers you need in TCP. For TCP, there is something called the Mathis equation. That is an estimation of how much you will be able to push through a TCP session based on latency, bandwidth, and percentage of packet drops. Usually with web applications, bandwidth or buffers are not a problem because we have loads and loads and loads of short responses. If you're trying to download loads of data, like you're downloading the whole Linux distribution, then obviously bandwidth delay product matters. For web applications, usually you are downloading loads and loads of small elements, and if the bandwidth on the path is on order of tens of megabits, then you don't really care about the bandwidth. You actually care only about the latency. Next one. When acceleration cache metadata such as non-HTTP 200 response codes? Actually, that function is done by the proxy servers, and it is tightly controlled, or should be, by the headers that web server uses in its response. HTTP proxies are the entities that cache things like HTTP responses and response codes, and what they can cache and how they can cache it is controlled with HTTP headers that are generated by the application or by the web server based on how it's set up. To get more information about my webinars, to register for an online session, or buy a recording or the yearly subscription, please visit my website.